Hi folks, welcome to Performance training program. In this training session, we'll be discussing about performance testing lifecycle. If you take the overall performance testing activity, right, like we can divide it into different phases. These are the phases that are part of the performance testing lifecycle. We start with the discover phase, then we go to the design phase, build phase, test phase, triage phase. And different people follow different test life cycle, but I have tried to encompass all the activities that happens in the performance testing in this 5 different phases. So let's get started with the discover phase. As part of the discover phase, the first thing that we do is identifying the test objective and goals. So we need to understand from the stakeholders or the product owner or the person who is funding this project, right? We need to sit with them and try to understand what exactly they want to do as part of this performance testing. There are a few people or few projects who just want to do the regular release regression test, and there are a few projects who wants to know how far application is capable of scaling up, and in terms of stability, in terms of reliability. So there are different objectives and goals, and different projects has their own objectives and goals. So we need to have a conversation with those key stakeholders and try to understand what exactly they want from this performance testing activity. So that's the first step that we do, right? Then we go with the requirement gathering phase. So as part of this performance test requirement gathering, what we do is like we have this template or the questionnaire template where we have this list of questions that we ask to the key stakeholders, and this questionnaire starts with something like this. We need to give the project name, what project for which we are doing the performance testing, and then the key POC. This is very important even for most of the questions or details that we need for the requirement gathering, right? Like we need to reach out to certain set of people. So we need to identify the key POCs of the project. Who's the engineering team, who's the support team, who's the test data management team, who's the solution architect. So we need to identify the relevant people from whom we can get the details that is required for executing this overall performance system. First we get the project name, then identify the POC, and then we try to understand the overall architecture view. We try to get the high-level diagram of the overall architecture, how many and technical specification of each of the application servers or database server. And we also try to understand what type of environment we use for our testing, if it's a test environment or if it's a pre-prod environment, how it is scaled compared to our production environment, and that clear details we have to get from them. Then we should also ask about the monitoring solution. Do we already have any monitoring solution in place or not, or do we need to set up the monitoring solution? That we need to ask. Then we also need to understand our test scenario. Now we know what application we are going to test, and inside in that particular application there might be a lot of user scenarios or the user action, like creating an account or browsing the flow. There might be a lot of functional test cases, out of which we need to understand what are the flows the business is interested for doing the performance testing. We'll again, if you see, there's one more section called test case identification. We'll talk about that. Okay, at a very high level detail, like we need to get the details of the journeys that the business is interested for doing the performance testing. Then we also need to understand what are the assumptions or what are the caveats in the test environment, and in terms of the data, in terms of the sizing, and in terms of the code readiness. All those things we have to discuss as part of the requirement gathering phase. Next comes the test candidate identification phase. In this section, what we do is now we have got the high level detail of the application flows which we are going to test. And sometimes there are projects which tell hundreds of or 50 or 100 functional test cases, and we should not be testing all those test cases. So we should identify our scenarios based on 3 major criteria. We need to select our flows test cases based on the criteria. Number 1, high volume transaction. We need to ask them, are these flows expected to have a high volume in production. So high volume scenarios we need to test, and very business critical transaction we need to test. When I say business critical, of course everything is critical, but there are few flows which are very critical for business. For example, in a checkout journey, right, the entire checkout flow is very critical for business, because even if one step is performing bad in that flow, right, people are going to abandon the website. So that is very critical. So all the critical transaction needs to be performance tested. Then there are transactions which involves a transfer of huge, humongous data set, right? The payload might be huge, or the response that is coming from that request might be huge. So those kind of data needs to be selected for our performance test. So based on these three criteria, we need to shortlist or pick only those ideal test cases for the performance testing. We cannot pick all the test cases that's there for functional testing. We cannot pick everything. We have to pick only the ideal test candidates, and we should do performance testing only for those test cases. Otherwise, we'll be losing a lot of time. Now we know what are the test cases that we are going to do. Then we can also get the walkthrough. Maybe if not in discover phase, we can have that in the design phase. We have to sit with the application team or the functional experts and get a walkthrough and try to understand the complete workflow of what are the user actions that they are doing, right? So there's also during that step we'll be creating a document called performance test case document. I'll be discussing when we are building the scripts, right? I'll explain you at that time. So next comes the environment setup. So as during the requirement gathering phase itself, like we would have asked some at least high level questions on the environment setup. Now we need to get all those details ready. What is the pre-prod environment looks like, the quality environment looks like, what are the application nodes or the number of servers that are in the test environment, and what about the code setup? Is it equivalent to that of the production, or it is n-1 or n-2? All those things that are required to ensure that the environment is ready, we need to check and ensure it's properly set up in terms of data. Another thing is the data setup that is used in the environment, right? Is it similar to the production, or is it like at least what I say? Ideally, it should be similar to that of the production data. Otherwise, we'll end up getting different response time in a quality system, but when the same code goes to production, we'll be getting a different response time. So we have to be very careful while doing this, or validating this environment setup. So next comes the proof of concept, defining SLAs and benchmarking. Okay, now we know the application. Now we need to understand which tool properly supports this, right? Maybe there are certain application which works well with load runner, and it might not be supported with JMeter. So we need to understand which tool works best for this application. So we need to do a proof of concept. Proof of concept is nothing but trying to script trying to take one flow and trying to do a sample script of that application, and checking whether the whole effort is doable or not. I mean, even before the project starts, these are something we need to do during the discover phase. We need to ensure whatever the available tool that we have in our project, using that particular tool, we will be able to script this application or not. Then defining the SLAs and benchmarking in some good standard projects, right? What they do is like they define the SLAs upfront. They will be telling you within how much time this particular transactions needs to respond. All those things, they will give industry standards as well. So they will be giving those service level agreement upfront. Service level agreement is nothing but what we are agreeing to. I mean, if there is a transaction response time, right? As a whole team, right? Maybe the development team as a whole, we are agreeing that this particular transaction is supposed to be responding within this time frame. That's called SLAs. And benchmarking, maybe sometimes we don't have the service level agreement. So in the cases, we need to run some test and do the benchmarking. We are setting up the SLAs for the application. Okay, so the next section is the performance monitoring strategy and approach. And most projects, they have their own monitoring tool. So we need to understand how this tool works, or there are certain key performance indicators. If we're talking about what is key performance indicator, we need to understand how we can get all those key performance metrics from that particular tool. And there are certain cases where we have to build some dashboard for fetching those key performance indicators. Most common metrics are readily available. So, but we should ensure that we are aware of it, and we are aware of the monitoring tools, and we have the required access for monitoring the application before we start the project. Then comes the performance test strategy. Performance test strategy is nothing but the document that tells all those details. Maybe we'll have a sample. We'll walk through a sample performance test strategy as what are the details that goes into the document. We'll be doing it as part of our exercise. We'll discuss that in the later section. So these are the things that happens in the discover phase of the performance testing lifecycle. So next comes the design phase. That's the second phase of the performance testing lifecycle. In this design phase, setting up the tooling infrastructure. Now we know we have done the proof of concept, and we have decided which tool best works for this application, right? Then we need to set up the complete tooling infrastructure, because as you know, using performance testing, we need to simulate a load of volume and big volume traffic we need to simulate. And for that, it's not possible just that we can run the test in our local machine. We need to have injectors. Injectors are nothing but machines that will simulate a huge volume of traffic. Maybe if one machinist can generate a traffic of say 300 concurrent users, right? And in order to generate 1,000 users, we need 3 such machines. We'll talk about that as well in the future. So we need 3 injectors. So we need to plan that complete tooling infrastructure. How many master machines are required, and how many slaves or the injector machines are required in order to simulate that required volume of traffic. So that all comes under the setting up the tooling infrastructure. Again, are we going with the cloud-based solution using AWS machines, or are we going to use local machines deployed in our local network? Those things we have to decide and set up the complete tooling infrastructure. Next is the test scenario design, test scenario planning and designing. Test scenario planning is that now we have identified the test cases, right? So test scenario is nothing but there are different types of tests. So we'll discuss about that in the coming discussion. Test scenario, how many types of testing are we going to do? Usually in most projects they will do load test, stress test, endurance test, and there are other tests which they might do on ad hoc basis. But these 3 tests are the common tests that gets executed in most projects. 99% of the projects ends up doing only these 3 tests. Okay. Now we know the test, then we need to design in a load test, how many users are we expecting? And again, coming back to the next section, we get in detail. At the test, when we say scenario, right? You need to understand what is the ramp up pattern, what is the steady state duration, how many transactions are expected. All those things that we have to design and plan our test. What are the types of tests we are going to do? All those things we have to plan it in the test scenario planning and designing phase. In the next section, workload characterization forecasting is nothing but it gives us the breakdown, based on some production analytics, right? For example, in real time, how much transaction or how much volume of traffic is being handled by the production. If it's software that we are going to test is already in production, we need to take that into account. How much of a traffic is coming for this create order transaction, or how much of a traffic is coming for a browsing a product page. So we need to get that numbers from the business analyst, or there might be someone from the analytics team, right? So we need to get those numbers. So based on those numbers, we need to again go back and design our test planning. So if we have 10 test cases, right? We need to properly allocate the number of users for each test cases so that it can achieve that amount of volume or traffic. Next comes the script development. And script development, we build the scripts. So we'll be discussing about how we build the script. Now we know the test cases, test flows. Let's take a checkout journey. So these are the transaction in the checkout journey. Now we have to convert that flows into script. using whatever tool, like if it is JMeter, we build JMeter scripts. If it's load runner scripts. If it's new load scripts. The script building activity comes under the script development phase. And then the test data management. This is very crucial and important step. Now we know the script. Now we need to feed the data, right? There might be in checkout, product, inventory. There are a lot of dependency on the test data. As most people would have been working in the functional test, you should have some background on the testing, right? So you know what is the critical role that test data management team or test data plays. So we need to identify what are the test data that is required for executing these test cases. Then we need to understand out of these data, what are burning data or what are the transactional data. I mean, in simple words, we can say like what are the master data and what are the transactional data. Master data is nothing but data, fixed value that's not going to change. We can use it any number of times. And transactional data is nothing but data that gets burnt or changes quite often. So those kind of transactional data also we need to understand. So now this for the transactional data, it is in few cases we need to understand how we are going to get that transactional data or update the transactional data. So we need to have a proper planning. There's a test data management team. We can give them a requirement and ask them to do that test data management for us. If not, we ourselves has to do it. Next comes the testing phase. So discover, design, build is most of these activities that are performed are a one-time activity. This test and triage is test phase and triage phase is something that we do quite often or we keep repeating. Testing phase, we start with the scenario creation. So initially in the last two phases we have planned the test scenario. Now we need to build the scenario in the tool, right? We'll be discussing about that. We need to build how we are going to mimic the workload, in what pattern, all those things, right? Like what is the ramp up time here? Ramp up is nothing but how many users are getting spinned up, what rate the request is moving to the system. So we'll cover that in detail. So we need to build the actual scenario in the actual tool. That's called the scenario creation. Then we do the baselining. So I talked about the benchmarking, right? That's nothing but the baselining. Whenever we do the test for the first time, right? That's more like a baseline test. So that's the metric that we use for the comparison of the any coming test. So the first test that we did will be used for comparison, and if there is any change or code level change or infrastructure level change that happens after this baseline, right? We again test that application, and we will try to compare this results with the baseline and see if anything has improved or degraded, and based on that we will be able to know this particular whatever the change that was introduced in the system has caused some problem. So that's called baselining. Baselining is the first test that we do in order to establish a metric for comparison. Next comes the test execution. Then we keep repeating the test execution based on whatever change that is introduced into the environment of the system. And every release we do that. Whenever there is a code change, we do that. Then there is a patch update. When there is an environment change. So every time there is a change in the system, we try to do the test. We try to execute the test and try to compare and see if there is any degradation in the performance or any improvement. All those things comes under the test execution phase. Monitoring, there are two types of monitoring. One is the client-side monitoring, server-side monitoring. We'll be discussing about what are the metrics that we capture as part of the client-side metric monitoring, the server-side metric. Client-side metric monitoring is nothing but a client, right? Client is nothing but your machine from where you are simulating the load. So from that, there are a few metrics, critical metrics like the transaction response time. So that we will measure from the client-side monitoring using that performance testing tool. Then we have the throughput. Throughput is nothing but number of transactions that are processed in a given unit of time. That is called throughput. So usually we will monitor transaction response time, throughput. Transaction response time, there are many metrics: average response time, 75 percentile, 90 percentile. So try to capture based on the client requirement. And throughput will capture like how many transactions are processed. Then pass transaction, fail transaction. So these are the key client-side metrics that we will monitor. And from server side monitoring, we have the monitoring tool already, right? So we'll try to indicator for monitoring other server side is like CPU and memory at all the applications, all the levels of application, right? Web tier, application tier, and DB tier, right? We try to monitor the CPU and the memory, because whenever even there is other problem, ripple effect on the CPU and memory. So it's the key metric that gives easy indication of the problem. So at least we have to monitor CPU and memory. On top of that, we can monitor a lot of other metrics, GC, disk usage, all those things. But CPU and memory are the key server-side monitoring indicators that we have to monitor for sure. Okay, so next we have executed the test, we have monitored, we have reported. Next comes the reporting. Reporting, there are certain key indicators, as I said, server side and the monitor will be reporting. Then comes the triage. So based on the reporting, right, like we'll be able to tell whether a particular application is performing good or bad. So once that is identified, right, we do the analysis, what exactly happened, compared to baseline, what are the changes that was introduced in this particular release, or what environment level change has been introduced. We try to do analysis, and if it requires a particular debugging, and there are some profiling tools, we have application monitoring tools. We try to debug that particular transaction that's having the problem, and try to look at the stack trace and see where exactly the problem is manifesting. And in certain cases, we will try to do some debug test based on the problem statement, right? Maybe if the problem is seen just on one particular transaction, we try to hit that particular transaction along with heavy load and see if there is any problem. So debug test is purely based on the rationale, based on your idea. Okay, so if we can, for isolating the problem, right, we need to understand what type of testing is required. So it's purely based on your rationale. You decide on how to do the debug test. Then comes the tuning. So once you've identified at which stack the problem is, whether it's at the DB or the application or the web, right? So we need to find, if it's the application level, what piece of code is causing the problem. Then we need to sit with the developer and try to understand and see if we can get a probable solution from him. If it's a DB, and if it's a SQL that is causing the problem, we need to work with the DBA team and see if there are some optimization that we can introduce, like indexing or other stuff, right? So that all those things comes under the tuning part. And this is the last thing, right? Like then we go with the reporting, go, no go, stakeholder communication. So once after we have done all those things, we try to report the problems, or the solutions, or whether sometimes at the end of each sprint cycle, right, we need to give the go or no go. If there are some potential big performance issue, right, the blocker issues, we typically give a no go from our performance testing side, and we spend more time in debugging the issue and trying to fix the issue, right? And all the stakeholder communication, reporting, all these things happens as part of the reporting. And once this is done for this particular release, right, or particular change that is introduced into the system, we again keep repeating it. It's an iterative process. Triage test is an iterative process based on whatever change that is introduced into the system. So I think we have covered the entire phase of the performance testing lifecycle. In order to attain our level of maturity in the overall performance testing project, right? So these are some key principles that you need to follow: planning, implementation, experimentation, adaptation, and continuous improvement. Planning, like you need to plan the overall project. So you're not plan just for that particular piece of work or something. You have to plan for the overall activity. So this whole discover, design, build, right? So you have to have that planning in mind, while working on this performance testing project. Next is implementation. Try to implement whatever you have planned. Sometimes whatever we implement might not work. So for that, we have to stick on to the experimentation approach, where we try to do some various experimentation and see what works and see what does not work, right? That's very essential. Then adapt it. Whatever works, let's try to adapt it. We have to adapt it and keep it as part of our standard process. Then on top of the process, we need to continuously improve. So if you are able to follow those key principles, right, you will be able to successfully run a performance testing project for any number of years. Thanks for listening to this video. And if you guys are interested in being part of our mentees club, check on this description. So there'll be a link which helps you to join our mentees club. Mentees will be communicated for about all the training programs that we take, and they'll be receiving some exclusive discount only for mentees. And we are also planning to conduct training only for a focused small audience, small subset of audience, and our mentees club will be given the top preference. Thank you. See you in our next video.